Our final sort of grouping is a somewhat niche one. This would be applications where you've got a high tolerance for losing your data. And these scenarios are quite rare. It's not a common use case for someone to say, I don't mind if I lose my data. I either can regenerate it from scratch, or it's not terribly important in the first place. If that's the case, why are you putting it into a database at all, would usually be the response. But occasionally this does occur. So before we get into it, I'll just cover one of the more interesting use cases I've seen in this vein. This use case involved a system of record over here. And this system of record, I believe, was a relational database of some sort. And this contained the entirety of the data that was going to be populated into MongoDB. And what had actually been done here was, at the application level, they had created, if you like, a map. So the application would look at this map, it would figure out where and on which instance the data it wanted lived, it would connect to that instance and retrieve data. This data was loaded in from the system of record, kept in memory in MongoDB, and then delivered from MongoDB via the driver to the application. So really they were using MongoDB, and in this case standalone instances of MongoDB, all running not even in replica sets, just a standalone MongoDB instance in each case on each host. They were really just using MongoDB as a caching layer here. If one of these died, they had a couple of different options. Either they could try and bring it back up and have it resync from the system of record, so fix it, bring it back up, resync it, and let this application go through, or they could just spin up a new standalone instance and populate the data in there. So with that being the case, I believe the deployment time for this was only a couple of minutes. In the meantime, while this piece of your data was missing, there was a pass-through option to actually hit the system of record and still get the data. So they didn't care if the data was lost in MongoDB. They didn't run with replication, they weren't doing that for availability. They had their own system for standing up a new MongoDB instance, and then this application would just redirect there once this was actually stood up. So in this particular scenario, a high tolerance for data loss, low requirement in terms of downtime. They didn't mind one of these instances going down for a period of time because they were able to replace it quite quickly, and that's the upper bound for a given outage. The only thing they would have really been concerned with, if a significant portion of these did all die at the same time, then you'd be hitting the system of record quite hard, and you might actually see capacity problems there. They didn't anticipate that actually being an issue. They were expecting to see failures across this sort of caching tier, but never anything so catastrophic as to affect the system of record. And to avoid that particular problem, you would probably spread these out across multiple data centers and things like that, multiple availability zones, etc. One of the things that we discussed as part of that sort of caching layer deployment was, should they use journaling or not? And the answer to this was yes. Yes, you should still use journaling. Journaling it's not necessarily there to guarantee that stuff makes a disk. That is one of the things it does, but what it's also doing is guaranteeing the consistency of the data on the disk, guaranteeing the sort of durability of things. The journal works as a sort of a check against getting on-disk corruption and things of that nature. Now, they could have run without journaling if they really, really wished, but at that point what we would have had to recommend to them is that they would run a check on the data themselves, because running without journaling essentially would mean that you're running in a sort of an untested, unknown state. We don't recommend running production without journaling turned on at all. So we should say yes, please, still use journaling, it's still a very good idea. Or if you do choose not to run with journaling, please implement some sort of way of verifying your data on a periodic basis, and if you find any inconsistencies, wipe it out and restore from your system of record again. So that was just an interesting point that came up as part of it. The recommendation was still definitely to use journaling. Now, with a high tolerance for data loss, your disaster recovery strategy is essentially going to be dictated by the other fields. So the question is, do you have a high or low tolerance for downtime? If you have a low tolerance for downtime, you're still going to need replica sets. And as we've seen before, if you want to bound that downtime and not require manual intervention in the two data center scenario, you're not going to have much luck. You're going to need a manual failover. So if a manual intervention for that failover is, again, considered unacceptable, your replica sets are going to have to be split across 3 locations. So we're back to the 3DC model. So you can see a lot of these arguments are going to repeat over and over again, depending on what your other requirements are. So is downtime allowed? Is downtime not allowed? If downtime is allowed, so if not, you're having the exact same discussion as we did previously, multiple data centers, probably 3 at least for automatic failover. It's kind of a branching argument here. So if you have a tolerance for downtime, is your branching argument. So if downtime, if you have tolerance, you're going to go standalone node maybe, if you've got a high tolerance for downtime. If not, maybe slightly lesser one would be the 2 data center replica set deployment where you need manual failover. So you'll have some downtime, hard to bound that again, so hard to build into a decent disaster recovery plan. If you've got no tolerance for downtime, we're back to having a replica set across 3 data centers, maybe even more. And then the other principle is your reduced capacity. And as we've seen and explored in the other modules, this is again, a branching argument. If you've got a tolerance for reduced capacity, maybe you deploy on VMs in the disaster recovery site, or maybe you deploy on lesser hardware in the disaster recovery site to cut costs. With no tolerance for reduced capacity, you end up with identical deployments in each DC so that the user experience, the application, response time, whatever your metric is the same even in the failover scenario. So these arguments don't really change. The high tolerance for data loss just means that you can usually wipe the thing and start again and not have to worry too much about doing backups and other things.